1.2 kg of liquid water initially at 15 degrees centigrade is to be heated to 95 degrees centigrade in a teapot equipped with a 1200 watt electric heating element inside as shown in the figure. The teapot is 0.5 kg and has an average specific heat of 0.7 kilojoule per kg degree centigrade. Take specific heat of water to be 4.18 kilojoule per kg degree centigrade and neglect any heat loss from the teapot. So here it is a linked answer question. It consists two questions such that the second question the answer depends on the first question. Here the first question is the amount of energy needed to raise the temperature of water and the teapot from 15 degrees centigrade to 95 degrees centigrade is, and here the second question is time needed for the water to be heated. So coming to the solution, consider the teapot and water together as a system and which is a closed system. So from the first law of thermodynamics, the heat transfer is equal to work done by the system plus internal energy developed in the system. But here the work done by the system is equal to 0. That is the work done by the water and the teapot is equal to 0. And here we'll have to find out the change in energy of the system and is given by mCp delta T of water and mCp delta T of teapot. So here the mass of the water is 1.2 kg and the specific heat is 4.18 kilojoule per kg degree centigrade and change in temperature is 95 minus 15 plus here the mass of the teapot is 0.5 kg and the specific heat of the teapot average is 0.7 and here it is 95 minus 15 is the change in temperature. So here it is equal to 429.3 kilojoules. So this is the amount of energy needed to raise the temperature of water and the teapot together from 15 degrees centigrade to 95 degrees centigrade. The amount of energy needed is nothing but the amount of heat transfer to the system. So here it is 429.3 kilojoule and in the option the right option is D. D is the right answer for the first question. Coming to the second question, here we will have to find out the time needed for the water to be heated from 15 degrees centigrade to 95 degrees centigrade. Here the provided heater is of capacity of 1200 watts, that is 1.2 kilowatts or 1.2 kilojoule per second, but the amount of energy or the amount of heat required is 429.3 kilojoules. So here the time needed is just the ratio of the amount of heat required to the rate of energy transfer. So here the amount of heat required are the total energy needed to the rate of energy transfer. Rate of energy transfer is nothing but the capacity of the heater. So it is equal to 429.3 and rate of energy transfer is 1.2 kilojoule per second. So which gives a value of nearly equal to 358 seconds or nearly equal to 6 minutes. So in the option the right option is C. C is the right answer for the second question. During orthogonal machining with a cutting tool having a 10 degrees rake angle, the chip thickness is measured to be 0.4 mm and the uncut chip thickness is 0.15 mm. Here it is a linked answer question. It consists two questions such a way that the second question answer depends on the first question answer. Here the first question is determine the shear plane angle and the options are 10.55 degrees, 21.55, 32.8 and 43.8. And here the second question is determine the magnitude of shear strain. So here the options are 1.73, 2.73, 3.72 and 4.72. So coming to the explanation, first we'll have to find out the shear plane angle. So you know that here the shear plane angle is pi, where tan pi is equal r cos alpha by 1 minus r sin alpha, where r is the cutting ratio or chip thickness ratio and here alpha is the rake angle and R is given by 0.15 by 0.4. 0.15 is the uncut chip thickness and 0.4 is the chip thickness, and it gives a value of 0.375, and from this we can find out the phi, that is shear plane angle, that is equal to tan inverse, where R is 0.375 and alpha is 10 degrees, and it is equal to 1 minus R, sorry, 1 minus 0.375 sin 10, so which is equal to 21.8 degrees, sorry, 21.55 degrees. So in the option, the right option is B. B is the right answer for the first question. And coming to the second question, here we will have to find out the determine the magnitude of shear strain. Shear, from the formula we can find out the shear strain, that is gamma is equal to cot pi plus tan pi minus alpha, where gamma is the shear strain, gamma represents shear strain here, and here cot 21.8 plus tan 21.8 minus 10, which gives a value of 2.73. So in the option, the right option is B. B is the right answer.